Okay, guys. So today we're going to look at how to do transport network analysis or transport network optimization using Excel solver. And essentially, network analysis is just optimization problem or optimization analysis where you try to achieve an objective. In this case, achieving the lowest cost possible to transport your products from one point to the other. So essentially, what you're doing is to minimize the cost of transportation, and that is the whole essence of doing this. So, before we dive into maybe solving a practical case, there's a basic concept that you need to understand, and then if you don't understand it, this whole thing will look like rocket science to you. So, let's look at what a transport network looks like. You know, so, this is like a typical transport network. Most networks are not this complex, but a typical network will likely look like this. You know, so you have what we call the nodes in the network. And a node is just like a point in your transportation network. You know, for instance, we can call this the originating point of our product. In this case, it could be a factory, it could be maybe a warehouse kind of. If you're into importation, it could be a warehouse where the journey of your product starts from. Mostly, this is a factory, a manufacturing plant, right? Then you have points in between where this could be a distribution center, maybe a national distribution center, maybe a regional distribution center, maybe a county distribution center, then maybe a distributor, and then a final customer. So all these terminating nodes are definitely your customers. So the terms we use to describe this are the nodes. Okay, so every point in your network is a node. So your factory is a node, your distribution center is a node, your customer is a node. Then for every two nodes that are connected by maybe a transportation system, that could be railway, it could be road, it could be air, it could be water, is an arc. So this node to this node is an arc. So we can call this factory one to distribution center one, or you can shorten it to say F1 to DC1. So this is an arc. The same way this to east is an arc, this to this is an arc. So every two connected dots or nodes in this case is what we call an arc in the transport network. So, and an arc will have certain parameters or properties, right? So, one thing that an arc must have or should have or always have is a capacity. So, the capacity stands for like what maximum amounts of goods or products you can transport between those 2 points. So, if the capacity of arc F1 to DC1 is maybe 700, it means that the maximum amount of goods you can transport is 700 along this arc at a time. So you can transport 701, of course, but then you can transport 600, you can transport 500 or 700, but you cannot transport more than 700, right? And then this will also have a cost. So the cost of moving one pack of food from here to here is not going to be the same as moving it from here to here because distances are not the same. Probably the mode of transport are not the same. So it will have different unit costs. Unit cost means the cost of transporting one pack of food. So assuming you transport 10 packs of food or of product, I don't know why I'm using food, maybe because I'm hungry. So the cost of transporting maybe 10 packs of products from here to here, let's say it is £20, right? And you're transporting maybe 10 units of your product, and you spend £20 in total. So unit cost is £20 divided by how many products transported. Of course, that is 20 over 10, which is 2. So that is the unit cost for this arc. So every arc along this line will have a unit cost. So now, what is the essence of all this? The essence of all this is to find how we are going to move all the products from this point till they get to this point, spending the lowest amount of money possible. Now that is where the unit cost comes in, and that is where the quantity transported along those arcs comes in. So we need to find a way to optimize those quantities transported across the arc so that we can get the lowest cost possible. That is the essence of doing this analysis, right? So I believe by this point, if you understand everything I've said, then you are good to go. So I'll come back to this later on, but let's look at the typical case of a transport network problem. I would advise to you to pause this video and maybe give yourself a few minutes to read through this so that we can proceed afterwards. Yeah, so I believe you must have looked at the question. You must have read through this and have seen the the case that we have to solve. This is a typical business case where you are being expected as a supply chain manager to optimize or show or bring up a plan on how to ship out these products, these foods that are made by this company from one point to the other, to your final customers. So they've given us a lot of information, and we need to sieve out what we need to use to sort out this. So first of all, we can see that we have different acts, and they have shown it to us. So these are the acts that we need to, the transportation network acts. So you can see we have K1 to B1, Kitchen 1 to Business 2, and you can also see the unit costs of each arc, and then you can also see the capacity of each arc. So you can see you can already see the constraints that you have or you need to meet up, and you can see the different nodes and their supply or their demand, right? So the first thing you need to do when you have a case like this is to pull up this information and put it into Excel. So first of all, you identify the arcs and put it down. You identify the unit cost, you put it down. You identify the capacities and you put it down, and then you identify the nodes and their supply or their demand, and then you put it down. And then when you have put down this information, then it's easy from there, right? So let's go to Excel and dive in. So I've already put down the arcs. So this is an arc, just just like this, K1 to B1. So from K1 to B1, from K1 to B2, just like that. So those are the arcs. Then the next thing is to put down the capacity, right? Capacity, and then the unit cost that they gave us, and then the nodes, and then the supply or demand, right? So all these things have been given to us, so we just need to put it up and fill it here. So I will just pause this video and fill it up from the question. Okay, now that we have put up all the information that have been given to us, so let me just go through them again. So these are the arcs. These are the arcs it has been given to us. These are the capacities has also been given to us. These are the unit costs per arc. These have been given to us. These are the nodes, the points in the network, which has also been given to us. Then the supply or the demand. Now you may be wondering why I have negative 1 2 or negative 1 4 in the kitchens. So I said I'm going to come back to this earlier on. I said I'm going to come back to this. So let me just show you now. So let's say this is a node and you have 50 packs of your product, or 50 of your products coming into that node, and at the end of the day you send out 50 of that node. So what is going to be the effective supply in that node? Obviously it's going to be 50 minus 50, which will be 0. So a typical case of something like this would be our distribution center, where we send out everything that comes in, just like in the case that we're trying to solve, right? Then this case is where you have 50 coming in and nothing going out. This could be a case like this, our terminating node. So we are not concerned about what happens after the customer buys it. So to our business, this is the end of the transport network. Maybe later on we're talking about reverse logistics. That's a different case. But then in this case of moving this product to your customer, this is the end of the products, right? So a case like this where 50 is coming in and nothing is going out is like one of your customers. So to get effective supply or the effective demand in this node is going to be 50 minus 0, which is positive 50 or plus 50 or 50. So if you have 50 coming in and 30 going out of a node, the effective demand or supply in this node is going to be 50 minus 30, which is 20. A typical case could be a warehouse where they can store, but they can still supply out of the warehouse when they need it. So you're not sending out everything. Something is left behind. Now you have a node where nothing is coming in, which is 0, and 50 is going out. So what could be a case like this? It could be that this is where your product is made. It could be your factory, it could be your plant, it could be maybe the warehouse. Is it warehouse? Yeah, maybe the warehouse where your the journey of the product is starting. Maybe you're importing the product, and your transport network is starting. Your distribution is starting from your warehouse. So something like that. But this is where the product is made. So in the case of our network here, it's going to be something like this node. So nothing is coming in and everything is going out. So as we have been doing all these ones, we say 0 minus 50, which is minus 50. If you press your calculator, you will see that this is minus 50. So I believe you understand now why this our kitchen is going to be minus 212 minus 1450, because 0 came in and this quantity is going out. So 0 minus 1002 is minus 1002. Perfect. So, and you can see that our businesses with our terminating nodes, they are positive. Very simple. So the next point is for us to begin to add our own columns. Now we have put down the information given to us from our manager. Then we need to put down some columns to help us to solve this question. Now the first column we need to put down is total cost, which is essentially what we are trying to find a solution of total cost, right? And by the way, if your column is overflowing like this, one thing to do, you can drag it to make it align, but then usually to make it easier, just double click on the line, and then it will automatically adjust to fit the column. So we have the total cost. Then another thing we need to add, column we need to add, is the shipping quantity, because we have no column for that. So we can add it anywhere along the line. We can add it here, we can add it here, but it's usually more visually appealing to add it next to your arc. So I will insert a column here. So I will click on this alphabet and right click, and then insert. I will insert the column. Let me insert another one. So let's call it shipping quantity, or shipping quantity, right? So I will double click here and then align it. So this is where our final values, in fact this column is the essence of all this thing we are doing here. We need to find the quantity we need to fill here to ship and don't go all these arcs. So let's format it to look differently. So let's use this. So now another column we need to add is we need to find a way to make sure that what we are sending here, what we are sending to these nodes does not exceed or does not fall short of our demand or our supply. So we can add something, we can maybe call it net flow. So let's add a column here and call it net flow. So all these columns that we added by ourselves, we created by ourselves, we cannot add numbers, but numbers like we cannot put down the numbers by ourselves. We need to use formulas. We need to assign values to them dynamically. So everything we've created outside of the ones given to us are going to be obtained by formulas. So what I mean by, for instance, this total cost. How do we get the total cost? Total cost is going to be the sum of the cost of shipping all the quantities here. And how do we get this cost? By multiplying the quantity shipped against the total cost. So quantity shipped times the total the unit cost is going to give us the total cost. I don't know if that makes sense. Yeah, that makes sense. So if you ship 2 here and we ship 4 here, or we ship maybe 3 here. No, let me make it easier. So if you say two quantities were shipped, 2 times 6 is 12. You put it down. The next one is 2 was shipped through this arc. So what is unit cost of this arc? Is 6.5. 6.5 times 2 is going to be 13. You know, so total cost of these two arcs is going to be this plus this, which should give us 25, right? So the same way you obtain this, we do it down to this end, so it will give us total cost. So we cannot be doing that manually because that will take ages. So we have a formula in Excel to give us that, and that is the sum product. So sum product. Now, by the way, if you are typing a formula and you want to auto-complete it, you can double click on it. I can double click on it to complete it, or I can press the tab button to complete it. So just so you know. So it will tell us to put in the arrays we want to find the sum product, which is this array and the cost array. So we wanted to multiply these two columns and sum it up for us. So that's it. You can see now we have 25 because we just have two values there, which is what we got earlier on. So we have 25. Then the next thing we need to find is the net flow. And how do we obtain the net flow? The net flow, like I explained earlier on, what came in minus what went out, right? So how do we get what came in and how do we get what went out? For instance, if you come for, let me use DC1 as an example. So what came in is a sum of the quantity shipped, right, when DC1 is the receiving node. These two means that they are the receiving node. So what came in is going to be all the quantities here when DC1 is here, is in the receiving node. So for instance, if I have 5, let me just add values to just illustrate. So let's say DC1, we have 5 here, so we have 5 plus. So it was only once that DC1 received. So DC1 received only 5 packs because that's the only one time you have it as the receiving node, right? So how do we get what went out of DC1? We sum up all the quantities here when DC1 is the sending node. This from means that you are taking it out from that node. So DC1, you have it here and you have it here. So what went out is going to be 5 plus 5. So 5 plus 5, so we have 10. So this is just an illustration, right? So these numbers are not what is supposed to be here, but it's just an illustration, just so you know. So we can say that what came in is 5 and what went out is 10, right? So that is how you get the net flow. But then we cannot do this again. We cannot do this manually. We have to use a formula to get that, right? So we come here, then let's use the formula bar because this is going to be very long. We use the sum if. The sum if is going to sum the values for us. If it will sum the values in the one column if a criteria is met in another column. So it will sum the values in this column if a criteria is met in maybe this column or this column. So the criteria here is going to be like maybe K1 or K2 or K3. So anytime it sees K1 here, it will sum up the values. So we want to get what went out. So we are going to use the two columns. So this is going to be the range. We are going to check the criteria. So we select the range, right? And then we lock it. And then we press comma. What is the criteria? The criteria is going to be K1. That is this. This is overflowing, right? Let me just close this. This one is making it look weird. Let me just use this to illustrate something so that it's not be weird, right? So, like I said, sum if. You select the range where we want to check for a criteria, which is this range. Then it's good practice to lock it because you don't want the cells to change. So you lock it. So it will ask you what is the criteria. The criteria is going to be K1, right? Then comma. Then the sum range where you are going to sum values if it meets the criteria, which is going to be the shipped quantities. So you select it and then you lock it. And then so this is going to give us the quantities that was shipped out of this K1. Sorry, the quantities that was shipped into 2. This is the 2 column, so it is the quantity that was shipped into. So how do you get what was went out? So the same formula, but then we are not going to sum it from using the from range. So the range now is going to be from, which is like it is the sending node. So whenever K1 is sending, we sum the values. So we lock it, then comma, we click here, and then comma, and then the shipping range. Shipping range is going to be this. Lock it as well, and the close brackets. So you can see that now it is 14 minus 14 because K1 only shipped things out. If you can see, you cannot see K1 receiving, so it was only sending out. So it's going to be this one plus this one plus this one plus this one. So that's 10 plus 4. That is 14, and then like it is minor because it is only receiving. I don't know if you understand what I mean. You see that this one's like this 14 is here is the outcome of this formula. This one is 0 because it is not sending, so 0 minus 14 is going to be minus 14, right? So that's it. So you can just copy down this formula and then it will do the same for all the other nodes, so that's it. So you might be wondering why some cells are locked and then I did not lock this one, right? Now let's see what happens if I did not lock maybe these cells. Let me close it, let me remove it, right? And then so if I copy this down and then I come to this other cell and I check, you can see that this one has moved down one single cell. When I only wanted it to come down, I only wanted this criteria to change. I want every other thing to remain the same. This is the only thing I wanted to change, which is this I3, because it changed from. So you lock cells when you don't want it to change, right? So now you can see that all the cells are moving downward one cell downwards. If I check this other cell, you can see that it has moved. In fact, it has entered a lot of empty cells. So when you don't want it, if you have a range that is constant, you don't want it to change, you lock it with F4 so that you don't fall into this problem. So let me just lock it back. No, let me do it again. Let me lock this, highlight it. F4, yeah. Then I'll copy it down again. Jesus Christ. Yeah, so we are now back to, we only have the criteria changing now, so we are correct. So now that we have our net flow, our total cost, and yeah, we can now put in the values in Excel, in the Excel solver, and then it will do its magic and give us the numbers that will give us the lowest cost of shipping. So we come to the data tab and we click the solver. In case you don't have this showing in your data tab, you just come to file and then come to options and then click on add-ins, and then you see solver add-in here, right? Then you click on it and then click on go. You can see I already have it ticked, so if it's not ticked, you tick on it and then click OK, and then it will appear in your data tab. So we click on it, and then what is our objective? Our objective is to minimize cost, so we have to select the cost. We want to put the value here, so this is going to be where our total cost is going to appear. So we want to get its minimum value. So we click on minimum. Then which cells do we need to change to achieve this aim? We need to change the quantity that we are shipping, which is this column, right? Then we add constraints. So we have a lot of condition one that we need to meet. The first one is that our net flow should be equal to our supply or demand. So we don't want to get supply more than what the customer requires or fall short of the demand, and we also don't want to supply less than what we have available from our kitchens. So we say that this should be less than, no, sorry, it should not be less, it should be equal to, right? It should be equal to this, strictly equal to. So we click OK. You can click OK, you can click add, whichever one you want to click. So we click on OK. Then you click on add again because we have another constraint. Another constraint is that these quantities we are shipping should be less than or equal to the capacity, right? So shipping quantities should be less than or equal to, is already selected. If it's not selected, you can just click down and then select it from the drop down. So less than or equal to the capacity, and then you click OK. So another constraint that we need to add is that, I mean, it's not so important, but then a lot of times if you're using some other software and you don't add it, I mean, it's good practice to put it in your subconscious. It might give you some decimal values as your shipping quantity, maybe 100.7. You cannot ship half of your products, and if you give your manager such number, the manager will look at you twice. Yeah, so we need to ensure that the quantities we are shipping should be whole numbers. So how do we do that? We add a constraint and say that this should be integers like whole number. Integers implies whole numbers, so it should be integers. So click on OK, right? So we have added our constraints. Yeah, there's no other constraints. So because this is a simple linear relationship, we just click on linear and then simplest linear programming, and then click on solve, right? And voila, solver has found a solution. All constraints are optimally and optimality conditions are satisfied, right? So you can see that this is going to be the minimum cost possible to ship these quantities to these locations. So you can see the quantities. You can see, even in some of the acts, we are advised not to ship anything because maybe it's very expensive, and then you can see that all the numbers here are less than the capacity or equal to, okay, no, they're all less than, and then you can even calculate to see if the demand maybe for B3 are met. Let's check. So B3 is receiving here, so it has 600 plus. B3 is receiving here 300. 300, and then B3 is receiving here 200. So you can see 600 per 300 is 900 per 200 8,100. So it's equal to what is their demand. So you can see that we're optimally meeting our conditions. So yeah, this is how you solve a transport network analysis. You can also put this in a pictorial format for your manager to see, but this is essentially what you need, this information, right? So you need this quantity. So you just give this to your transport manager or whoever is in charge, so that they can now see how to move these quantities along these axes for them to get to their final customers, final consumers, as the case may be. But you can draw a diagram to show it. What I mean is that maybe I've done it before. Let me just bring it up. Okay, I think it's in this. Yeah, no, it's not here. Yeah, so you have something like this, where you want to show it pictorially, so you just draw the diagram, like you can just put in a shape, a rounded shape. You can insert shape from here, shapes, select the shape you want to add, click on it, and then click on a arrow, click on arrow, and just resize it and make it connect to the what, like just kitchens, the node, just connect it together, and then write the quantities as they appear on that the server has given us, so that it can, they can see it visually, the quantity to arrive at, but essentially this is what you need, and yeah, that's what you need, and then you have arrived at your solution. So please like, and if you have any question, like the video. If you have any question, please put it in the comment section and I will do well to attend to them. And also don't forget to subscribe to this channel, because I am going to be putting down a lot of informative content, not just things like this, your everyday productivity hack for maybe your Excel, PowerPoint, Microsoft Word, and some other tech advices you're going to be getting from this channel. So please subscribe and click on the notification button, and I'll do well to provide a lot of informative content for your viewing pleasure. So thank you very much, and have a lovely day.